Given the function f of x is equal to x squared plus 6x plus 10, we're asked to find the relative extrema of this function. So, relative extrema, those are going to occur at critical numbers. Critical numbers are places where the function can change its behavior from increasing to decreasing. And the first derivative test, which is the only test we have so far to look for extrema, tells us that relative extrema will occur at points in the domain of the function where the function changes from either increasing to decreasing or from decreasing to increasing. So let's start with the derivative. F prime of x is equal to 2x plus 6. Let's consider any values of x that will make this derivative 0 or undefined. Hopefully you realize that it can't be undefined, but it definitely can be 0. In this case, when x is equal to a negative 3. The original function is not undefined anywhere. It's a polynomial function, continuous everywhere, defined everywhere. So this is the only value that we need to worry ourselves about. So we'll create a sign chart here. We'll let it go forever in both directions. Only worry about negative 3. And we'll test on each side. So we might consider f prime of negative 4 on the left and f prime of 0 on the right. So f prime is 2x plus 6. If I plug negative 4 in there, I'll get negative 2. That's negative. We're decreasing. If I plug 0 in for x, again into f prime, 2 times 0 plus 6 is going to be plus 6. So we're going to get a plus there. We're increasing. So around negative 3 on the left hand side we're decreasing, on the right hand side we are increasing. So that says that we should have a relative minimum here as long as negative 3 is in the domain of the function. Domain's all real numbers, we're all set there. So what is f of negative 3? And now I'm going back to the original function. F of negative 3 is negative 3 squared plus 6 times negative 3 plus 10. That is 9 minus 18 plus 10. 9 minus 18 is negative 9 plus 10 is 1. So this function has a relative minimum at the point negative 3 and 1. Now if you'd like, go ahead with your calculator, graph it, and see if that's what you find out. It's a parabola, so it should have a relative min since the leading coefficient is positive. Matter of fact, everything that you learned about parabolas will work out exactly the same way with calculus. We'll find exactly the same results. We're just using different, newer, and more powerful methods.